Hello students, I hope you are all well prepared for the test. Now, without wasting any time, let's start with our test. Okay, solve let's solve some problems. So the first question is that which of the following statement is or are correct about action and reaction? And the three options are given. First one is there is no cause and effect relation between action and reaction. Second one is action and reaction always acts on two different bodies, and third one is action and reaction forces are simultaneous forces. Okay, so this question is from the laws of motion chapter. So let's now dig into the solution. Here in the solution you can see that it is written that action and reaction forces are simultaneous forces. They act as simultaneously. Okay, and they act as simultaneously. Okay, and there is no effect of relation between action and reaction, as any of the two mutual forces can be called action and other one is reaction. Since action and reaction act on different bodies, so they cannot be cancelled out, right? So if you see your question, you can see there are first option is given only one, second option is only two, and the third option is only three, and the fourth one is all of this one, two, three. So here in the explanation you can see that action and reaction force act simultaneously, right? So that means second one is sorry, third one is right. Okay, and they uh, they acts on different these two acts on different bodies, so that means we can say the second option is also right, and we can say uh, there is no cause and effect relation. We can see this in our solution. Okay, so we should pick the option number 4 where all of these three are correct. Okay, let's move on to the next question. Okay, so in the next question you can see two figures. Okay, two rectangular figures. One is standard vertically and another is in horizontal. Okay, so the question states that a rectangular block is placed on a rough horizontal surface in two different ways as shown in the figure. So here the first option is given that friction will be more in the case of one, where, and second option is given friction will be more in the case of B, and third option is given friction will be equal to both the cases, and friction number 4, friction depends on relations among its dimensions. Okay, so as we know, friction doesn't depend on area of surface in contact with. Okay, so it depends upon only quality of the surfaces in contact and normal reactions. So therefore if we stand the object vertically or vertical plane or horizontal plane, it doesn't matter. So that means the friction will in both the blocks will be equal. So that means here option 3 is correct. Okay, now moving on to the next question. So in the next question it is also from the friction chapter. Okay, so here it states that the question states that if the coefficient of friction, coefficient of static friction, and coefficient of kinetic friction, and coefficient of rolling frictions, okay, are given. So what is the relation between these three, right? So as you can see in the explanation, the static force friction is the strongest out of these three, followed by the sliding friction, and then is the rolling friction. Okay, rolling friction is much smaller friction as compared to the static and kinetic friction. So the reason for being weak force is because wheels facilitate motion. Okay, so if you see the options here, in the fourth option the rolling friction is the smallest out of these three, as we can see from the explanation, and uh, kinetic friction is in between rolling friction and static friction is the strongest of them all. Okay, so that means option 4 is correct. So now moving on to the next question. The next question is from also laws of motion chapter. here question states what is impulse? Impulse is scalar quantity equal to change in the momentum of the body. Third option is equal to the rate of change of momentum of a body, and fourth option is a force. It's a force. Okay, so let's dig into the uh, solution. Okay, so we can see in the solution that force is nothing but the ratio of impulse and the time. Okay, so if we solve this equation, we can get that impulse is nothing but force multiplied with time. So therefore, we can say force force is nothing but the ratio of momentum and time. Okay, so we can say that if we solve this equation, we can get change in momentum, that means del p is equals to nothing but multiplication product of force and the change in time. Okay, so we can say and we know that impulse is nothing but the product of force and time. Okay, change in time. So therefore we can say force multiplied with time is equals to the change in momentum. So therefore option 2 is correct. Because it is equal to the second option is equal to change in the momentum of a body, right? So now moving on to the next question. So it is from the elasticity chapter. So the question states that there are two blocks of 4 kg suspended through a light spring balance A and B, where you can see the figure A and B are suspended vertically. Okay, and so you have to calculate the force acting on these two springs. Okay, okay, this block. Okay, so the options are 4 kg. First option is 4 kg and 0 kg. That means the action force acting on A is 4 kg and force acting on B is 0 kg. Okay. Now moving on to the next option is 0 kg and 4 kg. Third option is 4 kg and 4 kg. Second option is second kg, 2 kg and 2 kg. So let's dig into the solution. You can see in the given arrangement, right? You can see in the given arrangement the combination of spring they are in series. Okay, series combination. So therefore the force acting on the force acting on each spring will be equal. Okay, so as 4 k, you can see in the figure 4 kg weight is force is weight is suspended through the spring. So therefore, as we said earlier that in both the springs same amount of force will act. Oh, okay, so therefore we can say that in both the spring 4 kg and 4 kg force will act. Okay, so therefore option 3 is correct. Now moving on to the next question. There is a given there is a figure given, okay, where tension is with working in a certain rope. Okay, the length of rope is 2 meters. Okay, and 60 Newton weight is suspending from the rope. So if we solve the figure, if we get the free body diagram, we can say that if we take the solution, it is said that the horizontal component of T1 tension 1. Okay, the horizontal component of the tension working in the 2 meter rope is equals to the is equal to the T toward the second tension working in the rope. Okay, and T2 is also T2 is equals to the weight that is suspending from the rope. Okay, so it will be equals to 60 Newton. So therefore we can say T1 cos theta is nothing but 60 Newton. Okay, and also the vertical component of T1, that is T1 sin theta, it is also equal to 60 Newton, right? So therefore we can say that if this is equation 1 and this is equation 2, Okay, and if we divide these two equation, we can get T1 cancel out. Sin theta by cos theta will be equals to tan theta. Tan theta equals to 60 by 60 means 1. Okay, so therefore, the as we know that and 45 degrees equals to 1, therefore we can say theta is equals to 45 degree. That means option 2 is correct. Now moving on to the next question. Question number 7. It is a assertion reason question. So assertion is given: bullet is fired from a rifle. If the rifle recoils freely, the kinetic energy of the rifle is more than that of the bullet. Right. So the reason is given in the case of rifle bullet system, the law of conservation of momentum violates. Okay. Now, law of conservation of linear momentum is correct when no external force acts on it. Okay. When a bullet is fired from a rifle, they both possess equal momentum but different kinetic energy. And the relation between kinetic energy and momentum is A equals to P square by 2m, or you can say P equals to root over 2me. Okay. As the kinetic energy of the rifle is less than that of the bullet, because the kinetic energy is proportional to I by m. So having more m means less amount of E. You can see E is proportional to 1 by m, right? So therefore we can say that more the mass, less the kinetic energy, right? So therefore gun as the gun has more mass than the bullet, therefore we can say the kinetic energy of the bullet is greater than that of the gun. So therefore we can say option 4 is correct. That means assertion is incorrect, but the reason is also incorrect. Okay. Okay, moving on to the next question. Next question states that an explosion breaks a rock into three parts in a horizontal plane. Okay. Hmm. Two of them go off right angles to each other. That means this one. Okay. And the first part of mass 1 kg. This is the first part 1 kg. And the second at the speed of 12 meter per second. Okay. And the second part is this. This is the second part. This is a 2 kg part, and this moves with a speed of 8 meter per second. Okay. And the third part, this is the third part. Okay. This moves with the speed of 4 meter per second. You have to calculate the mass of this portion. Okay. How to calculate it? As we can see, if we take triangle law from vector, we can calculate the the resultant p, or the resultant momentum, that is equals to nothing but the square root of the total momentum of this one. Total momentum of this one will come 16, and this one will come 12. Okay, so that means here p resultant is 12 square plus 16 square, which will be equals to 20. Okay, 20 Newton second, right? So it is equal to the momentum. This 20 is equals to nothing but the momentum of the third part, that is p3. Okay, that is p3, right? So therefore we can say the p3 is equals to 20, and p3 is equals to m into 4, right? M into 4, that is equals to 20. Therefore we can say m is equals to nothing but 5, that is 5 kg. So that means option 1 is correct. Right. Moving on to the next question. The time required to stop a car of mass 800 kg. The mass of car is 800 kg. Okay. The speed of the vehicle is 20 meter per second. Okay. And it stops at a distance of 20 meter, 25 meter. Okay. So you have to calculate the time required to stop the car. as you know, you have to calculate the average v average, average velocity. Average velocity is, first it was in rest, so therefore the speed was 10, and then it got to speed of 20 meter per second. So therefore average speed will be 10 plus 20 by 2. That means 10 meter per second. Okay. So as we know that distance, the formula of distance formula is equals to v into t. Okay. So here v average should be, so v average, the value of v average is 10 meter per second, and the distance is given 25 meter. Okay. So 25 meter divided by 10, it will be equals to 2.5 seconds. Okay. So therefore option 2 is correct. Option 2, right? So moving on to the next question. A ball of mass 10 gram. The mass of the ball is 10 gram, right? Is perpendicular to the plane of a wall like this. It is perpendicular to the plane of a wall. Rebounds. Plane of the wall strikes it and rebounds. Strikes it and rebound. Okay. In the same line with the same velocity. If the impulse experienced by the wall is 0.54 Newton second. That means P equals to 0.54. As we saw in the earlier fourth number question, that impulse, the formula of impulse is change in momentum. So you have to calculate the change in momentum, right? So how to calculate change in momentum? Initially, when it is moving with certain velocity, right? If we take this velocity as v, okay, here it is v, right? So it is moving in the this direction, and it gets rebounded in this direction. Therefore, the velocity in this case is minus v. So the, if we calculate the del p, that will be equals to mv minus mv. That means the 2 mv. 2 mv is nothing but the impulse. The 2, that means 2 mv equals to 0.54, right? So therefore v will be 0.54 by 2, and the mass was given as 10 gram. So therefore we have to convert it into kg, that is 0.01. So if we calculate this, that then you will get the value of velocity is 27 meter per second. So therefore option A is correct. Okay, now moving on to the next question. The next question states that choose the wrong statement from the following. There are 4 statements are given. You have to choose the wrong one. The center of mass of a uniform circular ring is at its geometric center. This is the first one. Second one is moment of inertia is a scalar quantity. Third one is radius of gyration is a vector quantity. Fourth one is for same mass and radius, the moment of inertia of a ring is twice that of the uniform disk. Out of these 3 options, if you analyze the second option, in the second option, it is said that moment of inertia is a scalar quantity. As we all know, moment of inertia is a tensor quantity, neither vector or a scalar. So therefore, option 2 is correct, because you have to choose the wrong statement, as moment of inertia is a uh, tensor quantity. Therefore, it can neither be vector nor be scalar. So therefore, option 2 is correct. Okay. Next question states, which of the following is an are essential condition for mechanical equilibrium of a body? The first option is given, total force on the body should be 0. Second option is given, total torque on the body should be 0. Third option is both A and B are correct, and fourth option is total linear momentum should be 0. For the mechanical equilibrium of a rigid body, it should be in the rotational as well as in the transitional equilibrium. So therefore, rotational, that means torque and force. Okay, the net force and net torque would be equals to 0. So therefore, option C is correct. Option 3 is correct, because option C, it is right said that both A and B are correct. Right? Okay. Let's move on to the next question. A uniform square plate has a small q charge for irregular shape removed. Piece of q not the charge. A plate has a small piece q of an irregular shape removed, okay, and the glued to the center of the plate having hole behind. Then the moment of inertia about z axis, right? If you saw the diagram, right? If you saw the diagram, when this q is removed and glued to the center of the plate, right? The mass of the plate comes closer to the z-axis, okay. Hence, therefore, the moment of inertia decreases, okay, as we know that I is proportional to r square, right? So, as the r decreases, therefore, I also decreases, okay. So, therefore, option 2 is correct. Moving on to the next question. Question number 14. The moment of inertia of a circular disc of mass m and radius r about an axis passing through the center is I naught. Okay. The moment of inertia, another circular disc, same mass, same thickness, but the half the density of the same axis will be. You have to calculate that, right? Okay. Two circular discs are given. Both have the same mass, that is m, and radius r1. Moment of inertia is I naught for circular disc 2. This was for circular disc 1. Now for the circular disc 2, thickness was same, mass is also m, but the density, it has been halved, right? First it was rho, now it is rho by 2. Then first you have to calculate, you have to you have to calculate the mass. What is the formula of the mass is given like this, pi r square, that is the area, right? Now this is the thickness, that becomes volume, and this is our density, okay, which will be equals to the pi r1 square. That means the rho into T will come in. Therefore, the relation between R2 and R1 becomes R2 square equals to 2R1 square. As we saw, as we know that moment of inertia is proportional to the radius square. As I told you earlier, here I is proportional to R square here. Okay. So, therefore, we can say that I1 by I2 equals to R1 by R2 square. Okay. So, if you put the value, you will get I2 equals to I naught. So, therefore, we can say option 4, 2 I naught, that option is correct. Okay, moving on to the next question. The instantaneous angular position of a point on a rotating wheel is given by the equation small t equals to 2t cube minus 6t square. The torque on the wheel becomes 0 at. You have to calculate at which time the torque on the wheel becomes 0. So, first you have to calculate the angular axle, as the force or the torque acting on the object, the torque acting on the object, you have to calculate torque, you have to calculate 0. As we know, torque is nothing but I into alpha, where I is the angular, I is the uh, rotational acceleration or angular acceleration. So how to calculate angular acceleration? You have to you have to double derivative theta, okay, or the angular displacement, right? Two time differentiation, you will get the this is alpha d2 theta by dt2. This is alpha, okay. Angular acceleration, you have to, as I told you earlier, the angulation has to be 0 so that the torque can be 0, right? So this 12t minus 212 should be equals to 0. So therefore, if we calculate this, the t will come is 1 second. So therefore, option 1, t equals to 1 second, that is correct. Okay, now moving on to the next question. 16. Two bodies have their moments of inertia I and 2I respectively about their axis of rotation. If their kinetic energies or rotational kinetic energy E is equal, their E is equal, E1 equals to E2, right? The moment of inertia I and 2I. If the kinetic energy rotation are equal, the angular momentum, you have to calculate the ratio between angular momentum, right? If we see, The kinetic energy is given by the formula L square by 2I. So therefore we can say L square equals to 2I, where L is nothing but the angular momentum. This is angular momentum. Okay, and K is kinetic energy, and I is the uh, uh, I is the moment of inertia. So okay, moving on to the next. So if we put the value in this equation, we will get L1 by both. Therefore, we can say from this equation, the equation that is given at the bottom, we can say L1 by L2 is nothing but root over of, as it is said that L square is proportional to I, right? L square is proportional to I. So therefore, we can say L is proportional to root over of I, right? So therefore, L1 by L2 is equals to root over I by 2I, and L1 is to L2 therefore will be 1 is to root 2. Therefore, option 4 is correct. Okay, now moving on to the next question, that is question number 17. The ratio of radius of gyration of two circular disks above tangential axis in the plane of the disk and the circular ring of the same radius above the tangential axis in the same plane of the ring. Yeah, so the question states that there are two circular rings. Okay, first one, you have to calculate the moment of inertia for the first one, that is given by the formula mr square by 4, right? So that is about the center, the axis passing through the center, the axis passing through the CG. Okay, if we calculate this uh, moment of inertia about the axis passing through this axis, you have to add mr square with the moment of inertia about the uh, moment of inertia that is about the centroidal axis. So you will get mr square by 4 plus mr square. You will get 5 by 4 mr square. Okay. Another circular disc is given of circulating the same radius about. Now this one is a ring. Yeah, it looks like this. Okay, looks like this. You have to. We know this one is mr square by 2. Okay, so we have to calculate the moment of inertia about here. So we have to just nothing. We have to just add mr square to it. So we will get 3 by 2 mr square. Now if we take the ratios of these two, it will come 5 by 4 is to 3 by 2. Okay, right. Now radius of gyration. Okay, the radius of gyration. Okay, it will be, if we have to calculate the radius of gyration, it will be equals to r. First one is mk1 square, second one is mk2 square. Okay, so if we solve this two equation, we will get k1 square by k2 square equals to r1 by r2. Okay, so therefore k1 by k2 equals to nothing but root over 5 is to root over 6. Okay, understood, I think. Okay, now moving on to the next question. Solid cylinder of mass 50 kg and the radius of 0.5 is free to rotate about the horizontal axis, like this, like this. Okay, a massless string is wound round the cylinder with one end attached to it and the other hanging freely. Tension in the string required to produce an angular acceleration. Angular acceleration is 1 revolution per second square. Okay, now first you have to calculate that thing. First you have to calculate. We have to change. Alpha is given 2 revolution per second square. So therefore, the value will be, if you multiply it by 2 pi, you will get 4 pi radian per second square. It is the value in radian. Okay. Now you have to calculate the moment of inertia of the cylinder, that is half mr square. The mass is given 50 kg and the radius is given 0.5 meter. If we calculate this three, we will get 225 by 4. That means 6.25 around. Okay. Now we know that the formula that I already told you that the torque formula is I into alpha. I we already got the I is 25 by 4, and we got alpha equals to 4 pi. Okay, so if we calculate this, all of this, right, we will get the T, or the tension, right? The tension of the force is equals to tension of the string is equals to, if you follow this formula, Tr equals to I into alpha, that means torque. Okay, so therefore Tr equals to torque. So therefore you can get that T equals to torque by R. Torque was I alpha, right? Right, I alpha means 25 by 4 into 4 pi, and R is the radius, right? So therefore, if we calculate this two, you will get this 157 Newton. Okay, so therefore the tension on the wire is 257 Newton. Okay, now moving on to the next question. A grinding stone of radius 2 meter. Radius is given 2 meter. Okay, revolving at 120 RPM. So you have to calculate it into RPS. That means you have to divide by 60. You will get 252 RPS. Okay. Now, yeah, this is 2 RPS. Okay. Now, second one has the RPM of 660. That means you will divide it by 60. You will get 11 RPS. Okay. Now, here this time is given 9. Okay. The angular acceleration is, the formula angular acceleration is 2 pi omega 2 minus omega 1. Uh, the change in angular velocity by time. Okay, so you will get 2 pi radian per second. That is the angular acceleration. That is the value of alpha. Okay, now as we know that acceleration is nothing but the product between radius and the angular acceleration. Okay, that means A equals to alpha r, right? So value of alpha was 2 pi and the radius was 2. That means we will get the acceleration is equals to 4 pi meter per second square. Okay, that means option 2 is correct. Okay, option 2, that means angular acceleration alpha is 2 pi and the linear acceleration is 4 pi. Okay, now moving on to the next question. Just wait for a minute, I will explain it. Okay, this 20th number question states that to maintain a rotor at a uniform speed of 100 radian per second. Okay, that means omega is given 100. Omega is given 100. Omega is 100. Okay, that is radian per second. Okay, we don't have to convert it. An engine needs to transmit a torque of 90 Newton meter. So calculate the power. So the formula of power is torque into angular velocity. Angular velocity is 100. Okay, and the torque is 90. So if you multiply it, you will get 9,000 watt. That is equals to 9 kilowatt. So therefore, option 1 is correct. Option 1 is correct. Option 1 is correct. Okay, now moving on to the next part. Next question, that is number 21. The specific heat of gas at a constant pressure is greater than the specific heat of the same gas at the constant volume, because you have to know this thing. The first option is given, work is done in the expansion of the gas at the constant temperature. Second option is work is done expansion of the gas at the constant volume. Okay, and third option is given, the attraction between molecules increases at constant pressure. And the fourth option is the molecular attraction increases at constant volume. So let's dig into the explanation. Okay. When a gas is heated at a constant pressure, the gas is allowed to expand under a certain constant pressure. Heat is supplied used by raising the temperature as well as doing external work against the expansion. But when you when the volume of the air will be no chance of expansion. When there at the constant volume it is being expanded, there is no chance of expansion work. So therefore, the specific heat of gas, we can say the constant pressure is greater than the specific heat at a constant volume. Therefore, option 1 is correct. Okay, now moving on to the next question, that is 22. Now there is a system given. Okay, so when a system, the question states that when a system is taken from state I to state F along the path of IAF, this one, this one, right? It is found that the Q is 50, W is work done is 20 calorie. Right? Along the path of Q, along the path of IBF, this one. Okay, Q is 36. You have to calculate the W in this path. How to do it? So as we know, the internal energy is del U equals to nothing but Q minus W. So it will be 30 calorie. The value of U delta U is 30 calorie. Okay, it is for the IAF path. Now for the IBF path, Q is given, right? U is not given. W dash is also not given. As we know that the change in the internal energy doesn't depend on the path, so therefore the U will remain constant as it was in the case of in the IAF part. IAF part it was 30 calorie. Therefore, U is also 30 calorie here. So W dash is nothing but Q dash minus U dash. So the Q of IBF path was 36. This one. So and therefore and U was 30 that we calculated earlier. So therefore we can say W is nothing but 36 minus 30, that is 6 calorie. Okay. Now moving on to the next question. 23. 1 mole of diatomic ideal gas undergoes a cyclic process ABC, right, as shown in the figure. You can all see the figure ABC path like this. ABC path. Process is a adiabatic process. Okay, BC. Here this is the adiabatic process. The temperature at ABC are 400, 800 and 600. This is 400, 800 and this is 600. Okay, choose the correct statement. You have to choose the correct statement out of this the four statement that is given, that the change in the internal energy process CA this one is 700 R. Change in the internal energy at the AB this one is minus 350 R. Change in the internal energy at the in the process BC is 500 R. So out of these four, any option could be correct. Okay, now get into the we have to get into the problem. Okay, in the cyclic process, you know that the change in the total internal energy is zero, because the internal energy, as we told in the earlier numerical, that the change internal energy, the U, doesn't depend on path. Okay, so U, the calculation of the U should be by this formula, that is U n into CV into the change in the temperature. That mole number of mole is 1. Okay, and the value of CV, right, that is 5 R by 2 and del T is del T. So I have to calculate the del T. So del T will be 200 Kelvin. Okay, now putting this value, now putting other values in the first equation. Okay, so you will get what you will get. You will get the UBC. So the del T was 200. So if you put this value in this equation, if you put the value in this equation, you'll get in the del T we will put 200 and 200 2 200 100 into 5 5 means 500 R. So therefore the CV specificate at constant volume will be minus 500 R. Therefore option 4 is correct. A diatomic gas initially at 18 degrees Celsius, T1 18 degree, that is 209 Kelvin. Okay, initial volume is V and final volume the compressed at adiabatically to 1/8 of this original volume. That means if the initial volume is 8 V, therefore final volume will be V by 8. The temperature after the compression, you have to calculate the final temperature. As we know, this formula for the adiabatic process, T equals to V to the power gamma minus 1, that is constant. So therefore, we can say T1 V1 gamma to the power gamma minus 1 equals to T2 into V2 to the power gamma minus 1. Okay, if we put the values, we will get that T2 equals to 293. That is 291. It will be, I think, it will be 291. Okay, a little mistake. Okay, it will be 291. That is, and V1 by V2 to the power gamma minus 1. If we put the values for the diatomic for the diatomic gas, you know that the gamma is equals to 7 by 5. Gamma is equals to 7 by 5. So therefore, we can say gamma is equals to 7 by 5. If you put the value of gamma 7 by 5 minus 1, 7 by 5 minus 1 equals to 2 by 5. Okay. Now 2 by 5, 291 into V1 by V2, that means V1 by V2 equals to 8 to the power 2 by 5. Right. You will get something around 2.5, 2.7. Okay, so if you multiply these two, this one and this one, you will get that this value 668. That is the option number 2. Okay, now moving on to the next question, that is 25. Question number 25. It is also a assertion reason question. The efficiency of a reversible engine is maximum, that is the assertion, and reason is in such device no dissipation of energy takes place. Okay, as we know, in a reversible process, it is assumed that the efficiency is 100%. And there is no loss in the practical, which is not possible, but theoretically we study that. So both are true. Reason correct explanation is also reason and assertion both are correct. So therefore option 1 is right. That means assertion is correct and reason is the correct explanation of the assertion, right? Okay, moving on to the next question. If a body moving in a circular path maintains a speed of 10 meter per second, that means V equals to 10, then which of the following describe the relation between acceleration and radius? I have to derive the relation between acceleration and radius. As we know, for a centripetal force, acceleration is A equals to V square by given by the formula A equals to V square by R. So therefore, we can say if V is constant, V square will be constant too. So that the relation between R and A will be inversely proportional relation. So therefore, the as we know that if two physical quantities are in inversely proportional relation, their graph will be a parabolic, right? So therefore option 2 is correct. Now moving on to the next question, that is question number 27, I think. Okay, if the displacement of a body varies to the square of the elapsed time, then what will be what we will get? Okay, now if you know this equation, A is equals to ut plus half at square, where A is the positive acceleration. Okay, in this equation acceleration is constant and also the displacement. If the acceleration is constant, then S is proportional to and S is proportional to square of the 10. That means S is proportional to T square. It means for the given condition to be fulfilled, acceleration should be a constant, right? If the initial velocity is u equals to 0, therefore S will be equals to at square, half at square. And if half a is constant, therefore s will be equals to t square. Therefore, we can say the acceleration should be constant. Therefore, option 3 is correct. Right? Now moving on to the question number 28. Assertion. It is given that the speedometer of an automobile measure the average speed of the automobile. Reason: average velocity is equal to total displacement per time taken. As you can see in the assertion, it is said that a speedometer is a measuring device. But in the reason, it is said that you have to calculate average velocity by total displacement by total time. Right? So nowhere it is said that the speedometer the assertion, it is said the speedometer is a measuring device, but in the reason it is said that they are given an equation. So this do not this is not the correct explanation of the this is not the correct explanation of the um, correct explanation of the assertion, and assertion also is wrong, because the in this it is said that the speedometer is used for measuring of average speed, but it is not. It is used for the measuring of the instantaneous speed, the speed that you had in that instant. That is it is used for, okay, not for the average speed, right? So therefore you can say that both assertion and reason is incorrect. So therefore option 4 is correct. Now moving on to the next question, question number 29. The point traveled half the distance with a velocity of v naught. Half velocity, if we draw from one point to another point, this is first point, this is the first point, and this is the last point. So this portion is at v0 by with velocity v0, and the half of the remaining distance with covered with velocity v1. This portion is covered by v1 velocity, right? And with the velocity v1, second half of the remaining part is okay. So there this part is divided into two groups. This one is v1 and this one is v2. Okay, then you have to calculate the average velocity. Average velocity formula is given by total total distance total distance divided by total time, right? So if we have to calculate this, right, so we know that the formula of time is given by 2 d divided by 2 v naught, okay, right, d by 2. That means the half distance, this total distance is d, so this one is d by 2, this one is also d by 2, right? So from the formula s equals to vt, we can get that time is equals to d by 2 v naught, that is this. So average speed will be, the total distance is d, and the three portion, this here the speed is v naught, here v1 and v2, okay. So the time for the first part is d by v naught, second part is d by 2 v1 into v2, v1 plus v2, and the third part is also same, d divided by 2 v1 plus v2. So if we calculate all of this, you will get this 2 v naught equals to v1 plus v2, v1 plus v2 plus 2 v naught. So therefore we can say option number, therefore we can say the option number 4, option number 4, that is correct, that is the correct option, okay. Okay, now moving on to the next question. Okay, moving on to the next question. Okay. What is the question number 30? A rocket is fired up upward from the earth's surface, rocket for surface with a certain acceleration. A is given 19.6, which is twice that of g, right? And after 5 seconds, t equals to 5 seconds, its engine is switched off to the maximum height. You have to calculate h max, right? So it is a is nothing but 2g. Here it is calculated, a is nothing but 2g. The resultant velocity of the rocket after 5 seconds will be equals to v, that is it is stopped, right? So therefore final velocity will be 0, right? final velocity will be 0, right? And the v equals to u plus at. The initial velocity, final initial velocity is u naught. The rockets was it at rest at the initially, so therefore initial velocity is 0. If we put the values v equals to u plus at, the value of a is 2g, so therefore v equals to 2g plus 2g into 5, that means 10g. The maximum I have to, if you have to calculate the maximum, you have to put this formula, h equals to ut plus half gt square, right? As the u is 0, as u equals to 0, therefore h equals to half gt square, right? The half, in place of g you will put 2g, right? And then t, the value of t is 5 seconds, it is given in this, t is given 5 seconds, so therefore we will get h1 equals to 25 gram, 25 g. On switching of the engine, it goes up to a height of h2, let us say. Here the final velocity becomes 0. So therefore, if we apply the formula, this formula, v squared equals to 2 u square minus 2gh, because here the minus, because of it is moving in the upward direction, not in the downward direction. So therefore minus is given. The minus. So the value of u here is 10g. This is the initial velocity, right? This is the initial velocity for the second part where the engine is switched off. So therefore 10g square minus 2g h2. This h2 have to be calculated. The h2 is 50g. The initially it traveled 25g. Now it traveled 50g. So therefore the total height is 25g plus 50g. That means 75g. And the value of g is 9.8. Therefore, if we multiply these two, you will get 735. That is 735 meter. Okay, 735 meter. So that means 735 meter is the right answer. That means option 2, option number 2 is the right answer. Okay, now moving on to the next question, 31. In a projectile motion, okay, in a projectile motion, in a projectile motion, the velocity at the maximum height. If we draw the projectile motion, if this is the maximum height, h max, here you have to calculate the value of v. Here, this one. Here you have to calculate the value of v. How to calculate it? The maximum height in the projectile motion is given by the formula u square sin square 45 degree by 2g, right? So for there is projectile A, u square sin square 45 degree by 2g, and for the projectile B, it is u square sin square theta by 2g. If we say that these were equal, so therefore we can say the sin square theta is equals to, if we follow the steps, sin square theta will be equals to ua by ub whole square, where u is the velocity of the projectile A and ub is the projectile velocity of the projectile B, equals to sin square 45 degree. The sin square 45 degree value is 1 by root 2, to be square. That means sin square theta equals to 1 by root 2 square, 1 by root 2, that means 1 by root 2 square for the sin square, but this one is also 1 by root 2. So therefore we will get sin square theta equals to 1 by 4, that means sin theta equals to 1 by 2, that is the value of sin 30 degree. That means the theta will be equals to 30 degree. Okay, so right, this was the explanation for 32, right? Okay, now moving on to the next question. Sorry for the delay. Okay, moving on to the 33rd question. The stone tied up to the string of length L is whirled in a horizontal circle with a constant speed, like this, like this. Okay, okay. So this one is R. This one is R. Circle. If the stone makes 22 revolutions in 44 seconds, 22 revolutions, 22 revolutions in 44 seconds. Okay, so that the frequency, that means as we know that the frequency value of the frequency is nothing but revolution per time, number of revolutions per unit time, that is frequency. So you will get frequency equals to half, 0.5 second inverse or hertz, whatever you say, right? So now you have to calculate the value of acceleration, that is equals to pi square. Okay, acceleration equals to pi square. So as the speed is constant, so the tangential acceleration is 0, right? So once the centripetal acceleration is there, it acts along the radially inward direction, inward towards the center. The value of A is acceleration is pi square, and it acts inward direction towards the center. So therefore option 1 is correct. Okay, now moving on to the next question. That is question number 34. A projectile can have the same range r at two angles of projection. Okay, theta 1 and theta 2. Okay, if t1 and t2 the times to flight in two cases, then what is the product of these two times? Okay, there are two times t1 and t2. This is the t1 and this is the t2. They said that they have the same range for two angles of projection. One is theta, another is 90 degree minus theta. So therefore, T1 will be equals to 2u sin theta by g, and T2 will be equals to, as the formula is given, 2u sin theta by g. This is the real form. This is the formula to calculate the time taken for a projectile, the flight time. So if you multiply these two, you will get 2u into 4u square g square sin theta cos theta. Okay, so if you take this 2g, you will get u square sin theta by 2g, that is equals to r. So therefore you can say t1 into t2 is nothing but 2 by g into r. So therefore if these two, as we know that these two are constant, so therefore t1 into t2 will be equals to, will be proportional to capital R. That means option 1 is correct. Option 1 is correct. Okay, now moving on to the next question. This question from the vector chapter. If the vector 2 I cap plus 3 j cap plus 8 k cap is perpendicular to a vector 4 j cap minus 4 I cap plus a k cap, then the value of a, you have to calculate the value of a. So for this kind of numericals, you have to take the dot product of these two given vectors. As we know, I dot I equals to 1, simultaneously j dot j equals to 1, I dot j or I dot k both are equals to 0. So if we take the dot product, that means 2 into 4 minus 8, okay, 3 minus 4 12, and 8a plus 8a, right? So that means plus 4, that means equals to a equals to minus 4 by 8, that means minus half, right? Therefore option number 3 is correct. Okay, now moving on to the next question. Question number 36. Now you have already entered the section B. Okay, so 36 questions. The question number 36 says that a boat which has a speed of 5 km per hour, okay, has a speed of 5 km per hour in still water, crosses a river of with 1 kilometer. This one is 1 kilometer, okay, along the shortest path possible in 15 minutes. The time is 15 minutes. Okay, the time is 15 minutes. Okay, so you have to calculate the velocity of the river, right? We calculate the velocity of the river, right? So if from the question you can say that the time is 15 minutes, that is 1 by 4 hour. Okay, so therefore we can say V is nothing but if you calculate by the formula, that v will be equals to 4 kilometer per hour, and the vb, that is the velocity of the boat, that is 5 kilometer per hour. Okay, so this is the velocity of the river water. This is the velocity of the river. Sorry, this is the velocity of the river water. This one is the velocity of the river water. This is the velocity of the boat, right? This is the velocity is supposed to be. So therefore, v, the velocity of water, will be equals to, applying the Pythagoras theorem for this right angle triangle. You will get uh, v v square minus v square, right? So v square equals to, vb is 25, I think. This is 16. 25 minus 16 means 9, that is 3 kilometer per hour. That is the velocity of the water. Okay. Now moving on to the next question. That is 37. A particle of mass is projected with a velocity making an angle 30 degree with the horizontal. The magnitude of the angular momentum of the projectile about the point of projection when the particle is at maximum height h is. Okay, you have to calculate the magnitude of angular momentum, that is L, given by the formula mvr. The velocity of the projectile, let the velocity be v, and the angle was theta. So as we already told that L is equals to mvr. So if we have to take the, as the object is thrown not in a linear path. So for the, like this. So therefore you have to take the sine theta component, this one, sine theta component, right? So this is the sine theta component. So L equals to mvr sine theta component. The r will be equals to r sine theta. Okay, r will be equals to r sine theta. So we can say r sine theta, right? So r sine theta is nothing but the maximum height the projectile can reach. For total. Okay, so if you take the diagram like this is h, and this is also r sine, this is r sine theta. So therefore you can say h is equals to r sine theta, right? So L equals to, L was r mv r sine theta. In place of r sine theta, we will replace the r sine theta by h. Therefore L will be equals to mvh, and so h will be equals to, h is equals to, as from the, your formula, the formula was h equals to u square sine square theta by 2g. Here use, the velocity is v square equals to sine square, the angle is 30 degree here. So therefore v square sine square 30 degree by 2g. So therefore h equals to v square by 8g, right? For the horizontal component, this one, v v cos theta, right? The velocity is v cos theta, right? So velocity only at the present at maximum is u equals to root over u by root over 3 by 2. So putting the value in the above equation, we will get that L equals to root over 3 by mv cube by 16g. Okay, so therefore option 4 is correct. Now moving on to the next question, the 38. Question number 38. A stone of mass 2 kg is tied to a string of length 0.5 meter. If the breaking tension of the string is 900 Newton, right? T is 900 Newton, and the length of the wire is 0.5 meter, and the mass of the object is 2 kg. Okay, mass of the stone, right? Sorry, the maximum angular velocity the stone can have with uniform circular motion, that means omega. You have to calculate the value of omega, right? So the value, the tension, the formula of tension is, that is mr omega square. So if we if you put the values, right? So L is 0.5, T is 900, m is m is 2 kg, right? M is 2 kg. Okay, so if we put the values, okay, so we will get the value of omega, right? You will get the value of omega, that will be equals to, that will be equals to, So the formula was, what was the formula? E by 2m, right? E by mr equals to omega square. So therefore we can say omega equals to root over of 900, right here. That means omega equals to 30 radian per second. That means option 1 is correct. So now 39. There is a system given, right? Three objects. Uh, One is M1, another is M2, another is M3. Okay, like this. Three objects are given. So the the, the object at the left part, the farther left, the farthest left, has the highest mass, that is M3, which is applying F3 force on M2, and the M2 object applying F2 force on the M1, and the M1, the object with mass M1 is applying force F1 with F1, right? So therefore, if we calculate the common acceleration of the total system, right, because they are moving with the same acceleration, so you will get that the force applied by the object one, you have to, if you calculate this, the maximum acceleration will be equals to the force applied by the object 1 divided by the total mass of the system, that is m1 plus m2 plus m3. The force on m3, right, the force on m3 is, if this will be f3, okay, so this will be f3, right, this will be f3, mistakenly written, this will be f3, f3 is m3 into a, okay. So if we calculate, or if we put the value of f of a from here to here, you will get that force will be equals to m3 f1 divided by m1 plus m2 plus m3. Just put the value of a, you will get this. That means option 2 is correct. Okay, now moving on to the next question, that is 40, right? The force acting on a, if acting on a particle of mass m, okay, indicated by the force time graph. There is a graph, that is force time graph. The change in the momentum of the particle over the time from 0 to 8. Time del t is given, that means 8 minus 0, that means 8 second. Del t, that is del t, okay, 8 second. And you all know that the impulse is equals to force into change in time, okay. And you also know that from I think from the number 4, question number 4, that impulse is nothing but change in momentum. This is change in momentum, del p, change in momentum, okay. So area of the this graph means that the x-axis will be positive, and the if it is below x-axis, it will be negative, right? So finally, if we calculate, there are three, I think the three adjacent pictures are given. First one is the triangle, which will be calculated, the area of the triangle will be calculated by the formula half into b into h, right, okay. And the second one is a square, which is given, it is we have to calculate the formula, we have to calculate the area by formula L square. And third one is the rectangle, okay. So the formula to calculate the area is L into B. So if you calculate all these three and add these three, you will get the total amount of force, okay. The total momentum, the change in momentum, you will calculate the change in momentum, that is equals to 12 Newton per second, 12 Newton second, okay. Okay, moving on to the next question, that is a assertion and reason question. Okay, yes. The assertion states that if the net external force on the body is zero, then its acceleration is also zero, right? Reason, acceleration doesn't depend on force, right? Okay, as we all know, F is equals to, from the Newton's second law of motion, F is equals to ma, right? F is equals to ma. Therefore, we can already say that F depends on acceleration. So therefore, reason is incorrect. But in the assertion, it is said that if the force is zero, acceleration will always be zero. If the force is zero, this acceleration will always be zero. Zero by mass is equals to zero. So therefore, we can say the assertion is correct, but the reason is not the reason is incorrect. Okay. Moving on to the next question, that is 42. If the angular momentum of a particle, that is L, it is L, right? This is L, a radius r, uniform speed of L, the centripetal force acting on the particle is. To calculate the centripetal force, the formula centripetal force is mv square by r. Both in the case of centripetal and centrifugal, both are same. Okay, so if we put L equals to mvr and therefore V equals to L by mr, right? L equals V by so put the value of V like L by mr in the equation, in this mv square by r equation or this equation, you will get the value of centripetal force is L square by mr cube. That is option number 1. That means option number 1 is correct. So now moving on to the question number 43. 4 point of masses, each value m. The 4 points, this one, this one, this one, and this one, all have the same mass, that is equals to m. Okay. Now this is a square, right? Whose length side is L. Moment of inertia of the system x is passing through A and parallel to BD, right? If this is A and this is BD, this is the diagonal of the square. So you have to calculate the moment of inertia of this axis. The formula is simple, right? What is the formula? So you have to calculate the, that is so the if you have to calculate the moment of inertia about BD, right? About BD, right? You have to first, the formula that is applied, that moment of inertia of the point mass at B, right? This one, moment of inertia point mass at D, this one, and the moment of inertia point mass at C, this one. Okay, so therefore, if you calculate all this, you will get 2 into m into L by root 2. The L by root 2 means the this is the you have to take the half of the diagonal. Length of the diagonal is L into root 2, right? So half of the diagonal will be equals to L into root 2 by 2. That means L by root 2. So there L by root 2 is put here, right? And for the second part, it will be equals to the length of the diagonal. Okay, then this for this portion, this is this, and for the total whole diagonal, this is the portion. Okay, so therefore, if you add these two, you will get 3 ml square. That means option 3 is correct. Okay. For the 44 number question, radius of gyration of a body is a constant quality. Reason: the radius of gyration of a body. Right, one interruption. Radius of the gyration of the body is not a, or the assertion is given if the net external force on the body is zero, then its acceleration is also zero. Sorry, I moved on to the wrong question. Uh, Question number 44. Okay, radius of gyration of the body is a constant quantity. R is a constant quantity. Okay, the reason is given that the radius of gyration of a body about an axis of rotation may be defined as the root mean square, RMS. So the explanation states that the radius of gyration of the body is not a constant quantity. It depends. Okay, it depends on the position of the axis. Its value changes with the change in the location of the axis of rotation. Right. So like this, if if the so therefore you can say that radius of gyration of the body is not a constant quantity. Okay, so therefore assertion is incorrect. So this is right. The reason is given the radius of gyration of the body is about an axis of rotation may be defined as the root mean square. No, never. So therefore it is given by the formula root over I by m. Okay, that means I means inertia and m means mass. So therefore this option is also, so therefore reason is also incorrect. Therefore the option 4, that is assertion is incorrect and reason is also incorrect. This is right. For the 45th number question, particle starting with a certain initial velocity, that means there is some u. Okay, distance of covers a distance of 12 meter for the first 3 seconds, distance of 30 meter for 3 seconds, this next 3 seconds. The initial velocity, you have to calculate the value of u, calculate the value of u. Okay, so there are two parts, this one and this one. Sorry, my system is lagging. So this one is for 3 seconds, this one is also for 3 seconds. Okay, so it they cover 12 meters here and 30 meter in the next segment. This is 12 meter, this is 30 meter. Okay, now for the first part, right? So the distance traveled is total 12 plus 30 means 42, and the total time is 3 plus 3 6 seconds. Okay, if we calculate this by the formula s equals to ut plus half it square, right? So there is something u, right? So put the value of s equals to 42, right? And the u is no, there is no u. T is 6, so there was 6u plus the value of t is equals to 6 means 36. 36 by 2 means 18. Okay, so for the, so this is what the, so this equation is valid for the first one. First one means s is 12. Okay, for the second one this is this. So if we calculate this, the total value of e will be 1 meter per second. Okay, right. 46. A bus is moving with a velocity of 10 meter per second for a straight road. A scooter is twists to overtake the bus in 1 minute. Right? Bus, if the bus is at a distance 1.2 kilometers ahead, the velocity of which he has to chase the bus. Like it is like a thief and police numerical. Okay, the total distance it has to cover. This is the scooter, this is the bus. Okay, this is the scooter, this is the bus. The distance between these two is 1.2 kilometer, that is 1200 meter. 1200 meter, right? So we know that a is equals to vt. V is not given, so therefore and t is 60 seconds, I think. Okay, so that means v equals to 20. So the speed that it has to take, it has to be greater than the speed of the bus. Speed of the bus was 10 meter per second, so therefore its speed will be the velocity by which it has to travel, that is 10 plus 20, that is 30 meter per second, which is greater than the speed of the bus. The 47 question. A balloon moving upwards with a velocity of 12 meter per second, right? That means the initial velocity is 12 meter per second. Okay, right? A packet is released at a height of 65 meter. Like this is the balloon, and the packet is released at 65. This the height is 65 meter. Okay, so if we put the values and the formula AC equals to ut plus half at square, here AC is negative because it is traveling in the both direction. Okay, so the that means 65 equals to 12. That means the initial velocity is 12. That means 12t minus 5t square. If we calculate the equation by factorization, you will get t equals to 5 seconds. Okay. Okay. Now moving on to the next, that is the question from thermodynamics. Change in the internal energy of a thermodynamic system which was absorbed 2 kilocalorie of heat and done 400 joule. Okay, this is a simple question. So according to the first law of thermodynamics, it is said that total absorbed heat equals to internal energy plus work done. Q is given 2 kilocalorie, right? So you have to calculate into joule. That is 1 calorie equals to 4.2 joule. So you have to multiply it by 4.2. So we will get 8400 joule. And the work done is also given 400 joule, right? So that means the total internal energy is equals to total heat minus work done. That is 8400 minus 400. That means 8000 joule, which is equals to 8 kilojoule. You have to divide the joule by 1000, then you will get 8 kilojoule. Okay. Now moving on to the next question, 49. What will be the final pressure if an ideal gas of cylinder is compressed from adiabatically from one third of its volume? Already this kind of numerical is already done, right? So the formula that we will apply here is the P1 V1 PV to the power gamma equals to constant. Formula that we have to use is the P equals P V to the power gamma equals to constant. This is the formula. So from that you will get this P1 V1 to the power gamma. Sorry. The formula that you have to apply is P V to the power gamma equals to constant. This is the formula. From that you will get this P1 V1 to the power gamma equals to P2 V to the power gamma. On solving the equation, you will get P2 equals to P1 3 to the power gamma as the volume is one third. Okay, final volume is one third of the initial volume. So therefore, we can say that the final pressure will be change in pressure will be more than 3 times the initial pressure. Therefore, P2 will be equals to 3 times that of P1. So option 3 is correct. Last one, the last question states a monoatomic gas. A monoatomic gas at a pressure P and volume V expands isothermally to a volume of 2V. Okay, that means twice, the volume is twice. And the adiabatically to a volume of 16V. Okay, 16 times the final pressure of the gas. Same formula, PV to the power gamma equals to constant. So here are two, you have to do it in two segments, right? For first one, isothermally, and second one is adiabatic process. Okay, so in the first one, the V2 is equals to 2V1, and in the second one, the volume is 16V, 16 times. So if we put the values in the equation, you will get that P2 equals to P by 2 and V3 equals to 16V and V2 equals to 2V. So therefore, we will get P3 equals to P by 64, right? So that means the final volume, the final pressure of the gas will be equals to 1 by 64 time of the initial pressure. Okay, so that's it. So the whole paper is done. Go through the explanation part. Okay. Bye bye. I hope you understood all the problems.